Let's try this scenario. Okay, this is just the same as the determine the position of equilibrium, but it's just different scenario, different flavor here, right? But it's the same concept there. All right, let's select an appropriate reagent to accomplish this an acid-base reaction. So we have an acid which is an alkyne, right? Now, whether or not we're going to use sodium amide or sodium hydroxide, which ones will drive reaction forward to the product side? Okay. Well, let's write down two scenario here, two equilibrium. If sodium amide acts as a base, you will get this product right there, right? If hydroxide acts as a base, you get that product. Here we go. You get water, you get ammonia. All right. Now you just determine. So we have two equilibrium and determine which one go forward. Basically, look at the acid on both sides. So on the left side we have an alkyne pKa 25. On the product side we have ammonia. Right, there's an amine ammonia pKa 38. Does it go forward or go backward there? Strong acid, weak acids go to the weak acid side, go forward there. Okay. All right. The other one, so sodium hydroxide, you get water. The pKa of water is 15.7. Totally go backward. You know that? So if you want to deprotonate an alkyne, you go with sodium amide. Now you will learn this in the alkyne chapter. Okay. We don't use sodium hydroxide because you can see reaction go backward there. All right. Okay. All right, let's try on here. Once you're done, pause the video, and when you're done, check with me. All right. Now we have this compound is a ketone. The acidic proton is either this position or this position. Same pKa value there. Okay. Now add sodium amide or sodium phenoxide. This is phenol as an alcohol, right? We call sodium phenoxide, right? Like ethanol, ethoxide, methanol, and alcohol, and it's a base methoxide, right? So sodium phenoxide, which one's better? Let's draw out both scenario, both equilibrium, right? First one, start with sodium amide, abstract the alpha proton, you'll get ammonia. Now, sodium phenoxide does the same thing as a base, and you get phenol, like that. All right, determine who goes forward, who goes backward. So start on the left side, this guy right here, alpha proton, pK about 20. All right, about 20. On the right side, ammonia, pK 38. Phenol, this is not just a regular alcohol, it's like a super alcohol with a benzene ring, so pK about 10. Okay, so start from the top, 20 and 38, totally. Go forward. Sodium, remember amide is real like a devil. This guy really, really strong. Yeah, because its conjugate acid is really, really, really weak. Okay, this guy is really strong base, and it can react with pretty much everything. Now down here, so 20 and 10 totally go to the 20, go backward. So if you want to deprotonate this compound, pick sodium amide. Okay, sodium amide. All right, come down here. So now we will protonate this compound with an acid or an alkyne. Which one's better? Better reagent, a more appropriate reagent, right? All right, let's say what happened if this compound react with hydrochloric acid. The lone pair right here attack protons, react as a base, attack proton, and you get this compound, a chloride ion, right? Chloride ion. Now, if it reacts with alkyne, you get that, and you're gonna get this. All right. All right, let's see. So determine the equilibrium, right? So go forward, go backward. On the left side, the acid is right here, right? The acid is hydrochloric acid, -7, -8, right? Alkyne 25. On the right side, this is an acid, right? This looks like ammonia, amine. See that? Look like an amine, nitrogen. So pKa of ammonium ion is about 9. -7 and 9.3 totally go forward. Well, I'm sure you know that hydrochloric acid is a strong acid, protonate everything, right? Alkyne is a weak acid. You never use alkyne as an acid. Like no, if you want to do an acid, sulfuric acid, hydrochloric acid, hydrobromic acid, we always go to those. Okay, so this one 25 and 9 totally go back to 25, weaker acid side. Okay. All right, that's a little bit more application of using pKa. pKa can do a lot, comparing acidity, comparing basicity, right? Determine the direction of equilibrium, and determine the appropriate reagent. Okay. All right, we have chapter 3, class activity 2. This is question 1. Determine there's an equilibrium, left or right. We got use curve arrow for this guy to react with water. Okay, what product do you get? And pick 2 acidic proton using pKa. All right, and this we got question 4, and I give you the key down here. Okay, so that will help you out a little. All right, you know the drill. Complete it, upload it on Blackboard.